Functions versus call return. We've created many accidental problems by misusing call and return instructions to implement functions. I explore these issues and point to some ways that might help in backing out of this corner. Call and return instructions were originally included in CPU architectures to provide code sharing. Call return wasn't meant to support functions. It was meant to make code smaller. Here's a simple example. Imagine that we write some code and write it more than once. For example, we load R0 with some variable, we add 1 to it, and then we do it again, exactly the same. Load and add. Instead, we might rewrite the code to load the variable once in a subroutine, and then call the subroutine twice. Functions in mathematical notation mean something else. In mathematics, functions run instantaneously. This isn't true of call return code on CPUs. A central tenet of computer science is the revelation that one must use the principle of DRY. Don't repeat yourself. Instead of building DRY into our IDEs, we took the lazy way out and misused call to implement DRY. Currently, programmers are responsible for manually rearranging code in the form of DRY. Currently, programmers are responsible for manually rearranging code to fit. Currently, programmers are responsible for manually rearranging code to be DRY instead of letting the machine do the work for us. Why does it matter? The difference between pure functional rotation and call has caused many forms of self-imposed accidental complexity over the decades. For example, the ad hoc muddy thinking about multitasking, semaphores, priorities, etc. For example, the misbelief that destructured data is the same as multiple function parameters. For example, that the dimension of time